Alright, Railway Education Bureau, Stop, Think, Study, and Road to Progress. Instruction paper, unit number 23A, subject diesel locomotive operation running Alco GE switchers, copyright 1945 by DC Buell, Omaha, Postal Zone 2, Nebraska. This test does not discuss operating rules, requirements. It must be understood with the diesel locomotive engineers responsible for all ordinary operation requirements. Same as a steam locomotive engineer, he must know he has the proper supply of the diesel fuel, oil, lubricating oil, cooling water, sand, etc. Also, that he has other necessary supplies such as signals, flag, lamps. He must know various auxiliaries of the power plant and locomotive are working properly. He must make the required air brake tests. In addition, of course, he must obey all operating rules and safety precautions. Transition is the name given the traction motor circuit change if it take place either automatically or by action engineer during operation of the diesel locomotive. Transition, which takes place operation switching locomotive, described in the text. Electrical facts are about circuits and circuit changes, which are known as transition, are explained in section electrical action, unit number 23. Electrical reasons transition circuit changes must be made and explained in electrical section, unit number 25. Okay. A, throttle, reverse, B, reverser handle, C, automatic brake valve, D, independent brake valve, E, switch panel, F, instrument panel, H, cab heater, P, front cab window, rear sander, R, S, bell ringer valve, T, stand for engineer seat. That looks like that. Alright, diesel locomotive operation running Alco switchers. Checking starting stop of the diesel engine power plant. Alco diesel switching locomotive has been discussed previously. The test covers running Alco GE switching locomotives. 2. All operating rules, safety precautions must be observed as always before locomotive is moved. 3. Figure 1 illustrates engineer side of the cab of the 1,000 horsepower Alco GE switcher stands with the foreground support with the engineering seat with a view of the front cab window of the illustrates forward along the length of the hood of the locomotive. The side cab windows are at the right of the picture of the windows of the rear of the cab are directly behind with the engineer sheet with the names correspond with the letters figure 1 are listed below illustrations. 4. After the diesel engine has been started, it is running properly idle speed with the air pressure brakes and controls have reached 70 pounds or more. Locomotive can be started as follows. A. Press control switch, second switch from the top of the switch panel. E. Figure 1. B. Remove the reverser handle. B. From the middle position, the last notch of the direction in which the locomotive is to be moved. C. Make sure that the hand brakes are released. The air brake valve handles C and D are running in position. Pull back the throttle A about 1/2 inch as soon as the locomotive starts to move. Alright, this shows the cab indicators. 1. Engine start. 2. Control. 3. Fuel pump. 4. Front headlight dim. 5. Front headlight bright. 6. Right headlight dim. 7. Red light dim. 8. Gauge lights. 9. Dome light. 10. Engine compartment lights. 11. The number lights. 12. Marker lights. 13. Heater fan. The slack is taken up with the throttle can moved out for another inch or more, then pulled back further gradually to accelerate the motion. And acceleration is faster than necessary. If the speed increases beyond that required, the throttle should be eased off by returning it to the forward idle position. Stop the locomotive. Return the throttle to the idling position. Apply with the brakes necessary to reverse the locomotive. First, bring the locomotive to a dead stop. Move the reverser handle to the extreme opposite position. Pull back on the throttle as before. 7. Figure 2 close-up view of the control stand instrumental panel shown in figure 1. Names of the control light switches numbers at the top of the bottom are shown under the illustration plate with each switch carries the name of the switch. The various indicators of the gauge panel shown in figure 2 explains as follows. The upper left-hand gauge of the duplex air brake gauge of the right hand shows the main reservoir pressure of the right hand shows the equalizing pressure. Lower left-hand gauge and another duplex air brake gauge of the right hand gauge shows the brake cylinder pressure of the right hand shows the brake pipe pressure. The ammeter, the middle instrument over the top of the panel, similar to the light ammeter of the dashboard over the automobile hand points to the right, shows the auxiliary generator is charging battery at what rate. What hand points to the left shows the battery is discharging it at what rate. The upper right hand gauge, the gauge shows the pressure of the fuel oil line of the Bosch injection assembly should be read about 35 pounds fuel pump is running. Middle gauge at the right with the air gauge which shows the control pressure operating air pistons which move the reverser drum and the traction motor contact with the gauge show about 70 pounds of pressure. Reverse will not operate. and the locomotive cannot be started until sufficient air pressure to operate these switches. The lower gauge at the right, the gauge of the pressure of lubricating oil, which is being delivered to the bearings of the engine. The gauge should read about 35 to 45 pounds at all times the engine is running. May show higher pressure when the engine is first started, especially if the oil is cold. The thermometer, the middle gauge at the bottom of the panel, shows the temperature of the engine cooling water should reach between 150 to 170 degrees. Engine running. After the engine has been started, the locomotive should not be used to handle load under thermometer shows at least 125 degrees. Hinge cap. The cap at the center panel covered to the electrical light bulb illuminates the differential dial. The light is turned on by operating the gauge light switch. The eighth of the top of the bank of the switch side of the panel hinge allow the cab to be raised if necessary to replace the burnout bulb. There's an overload light which does not show on either figure 1 or figure 2. It's below instrument panel line of the lubricating oil pressure gauge. It has been seen in figure 11 unit 22A at G. Throttle A of the top of the instrument panel is latched to the idle position forward stop. No current is produced by the main generator while the throttle is idle position. Latches relief the throttle is moved with the first half of the inch of the idling position is given to what's called the soft start. This half-inch movement it makes for the electrical contacts which set up the circuit so the limited supply of electricity is furnished to the traction motors at an amount which is sufficient to move the locomotive to start a few cars. 10. A soft start position should be used when spotting cars. A couple of passengers which would be to be switched. There is no start in the soft start position on the throttle of an older 660 horsepower switcher. If a heavy loaded switch, the throttle should be moved out about half an inch and a half after the spike has been taken up. The increased movement closes additional electrical contacts which set up the other circuits. These circuits should apply increased power to the motor starting heavier loads. 11. There are no notches on throttle on the 660 horsepower or the 1000 horsepower switcher except where the throttle is latched to idle position. Throttle movement away from the idle position is transmitted with the two electrical contacts shown in figure 3 with the system of the lever known as throttle linkage, which is shown in figure AAA of figure 4. First half-inch movement of the completes the circuit lower with the two contact blocks shown in figure 3 with the second movement that completes the circuit with the upper contact block. Additional movement of the throttle affects only with the mechanical throttle linkage. 12. The following electrical action takes place when the throttle is moved away from the idling position. First circuit complete with the operates electro-pneumatic valve so that the reverser drum is turned to the proper position. Forward or backward movement of the locomotive according to the position reverse handle. Second, with the movement of the reverser drum sets up required circuit from the generator traction motors. Also, with the excited field contactor closed, the third generator field contactor closes the last circuit supply with the current from the excited to the coil of the field magnets of the generator that begins to deliver current to the traction motor. Further, the movement over the throttle does not have an additional electrical effect on the circuits. However, the movement over the mechanical throttle linkage causes the governor to operate so that the increased amounts of fuel oil are delivered to the cylinder engines. 13. Diesel engine runs about 275 revolutions per minute with the throttle idling position. Movement of the throttle away from the idle position causes the engine's speed to increase up to 740 revolutions per minute at full throttle. The throttle is moved clear from the oil out of the idling position quickly instead of gradually. The engine may speed up faster, but the governor can react. If the engine speeds up much above 740 revolutions per minute, the overspeed lever will trip and shut off the fuel supply of the engine. Engine will stop. The overspeed will trip to be reset by hand. The engine can be started again. 14. Throttle never shall be pumped back and forth. The pump from idle position back to idling. It will make the brake electrical circuits rapidly unnecessary. This is likely to cause electrical contacts, arcs, and burns, so it may result in locomotive failure. 15. The definition notch of the throttle quadrants of some of the road locomotives. Movement of throttle notch to knot position produces an increase of the engine speed, means electrical controls instead of the mechanical connection. Throttle should be moved from notch to notch gradually. This arrangement time should be allowed for the governor to adjust the engine speed to each changing throttle position. 16. Locomotive is reversed by means of the reverser handle at the top of the control. Seats to front instrument panel figure 2 show the end handle in its mid and neutral position. It has 3 notches forward and 3 in reverse. Locomotive can be moved with the forward and reverse handle, and one of the 3 forward notches can be moved backward with reverse handle, and in one of the 3 backward notches. Where the second and third notch positions are indicated by the lines of the quadrant figure 2 field with the reverser handle. Tell whether each notch is reached. Ordinarily, a reverse handle is moved clear forward, clear back, in accordance with the direction in which the desire to have the locomotive. The different notches control the transition circuits. Alright, transition. 18 traction motors with a diesel locomotive with a connecting series of starting low-speed operation method. The electrical connection gives the maximum tractive effort of the torque at a low speed. On all Alco GE switching locomotive, there is arrangement changing the traction motor circuits from series to series parallel. As soon as the locomotive with the train speed reaches 6 miles per hour, the change of the circuits is known as transition. As speed increases, the traction motor consumes less current because of the counter electromotive forces generated. However, the voltage generator increases the additional current supplied by the traction motor. The change of the traction motor circuit of the series parallel must be made before the voltage of the generator rises above practical limit. 19. All Alco GE switching locomotives, there is a provision second transition. Second transition is the series parallel shunt. This is the second transition useful at higher speeds. 20. On some locomotive, transition takes place automatically. On Alco GE switching locomotive, the transition may take place automatically, or the engineer of the control transition by placing the reverser handle in the first or second 30 notches in the direction which the engine is to be moved. Thus, the reverser handle serves also as a selective transition control handle. 21. In the first notch away from the mid of the neutral position, either the direction circuit will remain in series irrespectively of the speed. In the second notch, the circuit will change from series to series parallel automatically at 6 miles per hour and then will remain in series parallel. In the third notch, the circuit will be in series at starting the shift automatically from series to series parallel at about 6 miles per hour and will shift again automatically from series parallel to series parallel shunt or reduced field at about 23 miles per hour. 22. Speeds usually at low yard switching loads are fairly heavy. Under these conditions, selective transition is desirable. The engineer can play with the reverser handle in the first notch hole of the traction motor circuit in a series as long as desired. 23. When the locomotive is being used in light, fast switching, reverse handle can be to the left in the second notch. This allows the automatic change of the circuits of the series parallel as speed picks up during the short moves. 24. On light or long runs, such as transfer service, the reverse handle should be moved to the third notch so that the circuits will change automatically series parallel, then series parallel to shunt at higher speeds. When automatic transition takes place, the circuit change is accomplished by automatic closing of the transition relay. But the closing of the transition relay is brought about by the increasing generator voltage as compared with the amount of current flowing with the traction motor. Generator voltage increases if the traction motor speed increases in the grease, and again when the transition series parallel takes place. 26. On switcher transition relay designated as pickup of the locomotive speed risen to about 6 miles per hour. The transition relay picks up the succession electrical changes occur. As a result, the traction motor contactors operated by air pressure air valves operated electronically move the traction motor contactors change the circuit of the traction motor from series to series parallel. The overload light may flash the instant the transition takes place. 27. When the circuit changes from series to series parallel, more current flows with the traction motor, the voltage generator drops accordingly. This drop in the voltage always in the transition relay to the dropout to open again. However, dropping out the relay at this time does not have an effect with the traction motor circuit which have been set up. The increased current flowing from the traction motor results in further increase in speed of the locomotive. 28. When the speed of it has increased about 23 miles per hour, the voltage of the generator will have increased again sufficiently in proportion to the current flowing of the traction motor. Cause transition relay to pick up the second time. Second pickup of the transition relay causes a change in field circuit with the traction motor. Second circuit change if known as series parallel shunt or reduced field. It results further increase of the locomotive speed. 29. Backward transitions, namely you describe the change of the traction motor circuits from serials to shunt back to series parallel, from serials parallel back to series. Backward transition from serials parallel shunt to series parallel is desirable and necessary when the engine is working at full power and locomotive speed drops about 16 miles per hour. It occurs automatically under these conditions. 30. Similar to traction motor circuit should be charged with a series parallel. The series locomotive speed drops back to the 8 miles per hour or less. Otherwise, quite likely the locomotive will be overloaded with the damage may be done to the traction motors. Backward transition from serials parallel to series must be made manually by the engineer. 31. Manual transition, that is the change of the traction motor circuit with the series parallel to series, is made properly by easing off the throttle, then moving the reverser handle the third or second notch back the first notch. This movement of the reverser handle causes the traction motor contactors to restore traction motor circuits to series, after which the throttle can be moved out again as desired. 32. After first and second transition have taken place, manual backward transition will occur with the reverser handle to move the third notch to the second and with the second notch first. This change will take a respective speed, but the other condition throttle always should be eased off before making backward transition for any reason. Alright, 33. Overloading warning signal is cut into the traction motor circuit only when the circuits are a series parallel shunt. Connected with the circuit that so that the light up of the load of the traction motor increases beyond the safety operating limit. When the warning signal lights up, the throttle should be eased off the reverser handle to move to the next lower notch. If this overload warning light is not needed, headed, it's probably that the traction motor will be overheated sufficiently to cause considerable damage. Locomotives overloaded that cannot handle with the cars are more than 6 or 7 miles an hour when the traction motor circuits are in series. There is no signal to show this. However, the motors will overheat if the train load is not reduced properly. 34. When traction circuits are in series parallel, locomotives about to ascend the grade, they will require a change in circuit back to series. As best practice to move the reverser handle back the first and second series notch, where the locomotive still is approaching the grade at a fair rate of speed. Only a little speed will be lost easing off the throttle, moving the reverser handle to the first notch at this time compared to making some of the move with the speed with a drop down to 8 miles per hour on the grade. There is no opportunity to go run for a hard pull. The best approach to the grade with a reverse handle in the first or series notch. 35. On some road switchers with a reverser handles alongside of the throttle at the top of the instrument panel where the multiple unit control is installed. With this, there is an ordinary throw switch directly from the instrument panel, which is known as the series holding switch. When switch is in one position, the S position of the traction motor circuits are held in series at all speeds. In opposition, SP position transition to series parallel and to series parallel shunt occurs automatically. The switch must be thrown to the series position to move backward transition from series parallel to series. On the road switchers, which have multiple unit control, the throttle has 8 notches addition with the idle speeding, moving the throttle from one notch to another. Set up the electrical circuits to operate electro-pneumatic valve, the engine governor. These valves also increase the engine speed. Stopping locomotive. 37. Alco GE switching locomotives are equipped with ordinary Westinghouse New York automatic air brake equipment. The equipment shown in Figure 1 is Westinghouse number 14 EL, quite similar to the number 6 ET equipment. There's no practical difference between installation with equipment of diesel locomotive, the ordinary steam switcher, except for the necessary difference in design and application for the brake rigging. Both brake valve handles can be removed for the brake valves. 38. To stop a locomotive with a train, the throttle shall be shut off with a brake applied to any of the switching locomotives necessary to operate the standards in stopping. They should be operated the same as they would be steam switching locomotive. Alright, reversing locomotive. 39. Locomotive is reversed by changing the direction and flow of electricity with the field of the traction motor. The electrical change is produced after the reverser handle has moved to the reverse position. Then when the throttle is open and the circuit is closed with the control air valves, the turn of the reverser drum and an electrical apparatus cabinet with the turning of the drum sets up the desired circuits. 40. The reverse handle should not be thrown from the forward to reverse to forward while the locomotive is in motion. When the locomotive has stopped the throttle in the idle position, reverser handle move to the opposite position, then the throttle can be moved away from the idling position to cause the locomotive to move again. 41. When the throttle is moved away from the idling position, a locking coil regulates the movement of the reverser energized electricity. With the throttle open, the reverser can be turned in any position. Mid-position cannot be moved in the reverse. A move of the mid-position cannot be moved out of the mid-position again until the throttle is returned to idle position. Interlocking is not operating in the throttle's idle position. Therefore, locomotive is drifting as possible. Move with the reverse handle to the opposite position. This must not be done. If the throttle is moved from the idle position, moved before the locomotive stops, the electrical circuits will be completed. If it is, the throttle is moved from the idle position before the locomotive stops, the electrical circuits will be completed, which will cause the contacts to arc and may cause flashover of the traction motors that will cause serious damage. 40. Automatic alarms and safeguards. 42. Locomotives equipped with 2 automatic alarms, 3 automatic safety devices. The 2 automatic alarms are generator overload relay. This causes a signal lamp with the glow of a load over the main generator reaches the safety level. Signal operates only when the traction motor circuits are in series parallel or in series parallel shunt. 2. When wheel slip buzzer, wheel sounds when the driving wheels are slipping. Some of the locomotives are equipped with the operating wheel slip relay automatically stops slipping. 43. The operational overload signal has been discussed in paragraph 33. 44. Wheel slippage indicated with the intermittent buzzing of the wheel slipping indicator located at the bottom of the switch panel in the cab. When wheel slipping is indicated, the throttle should be eased off immediately. When the wheels have stopped spinning, the Sanders can be opened and after the throttle can be returned gradually to the former position. Sanders must not be opened when the buzzer indicates if the wheels are slipping. The same if it is used improperly. It is quite likely slipping may be stopped so suddenly that the teeth of the traction motor pinion will shear off. The other similar damage will occur. 45. If the brake sticks or one pair of wheels on the truck slides and the locomotive pulls away with a stop, the buzzer will sound continuously. This warning must be headed immediately. With the independent brake valve, the handle should be moved to the release position back into the effort to kick off the brake. If the buzzer still sounds, the locomotive must be stopped and the cause of the wheel sliding corrected. 46. The wheel slip buzzer is not designed to indicate whether the pair of locomotive wheels is sliding. There will be no indication of sliding occurring while the throttle is in idle position. There will be no indicating of the both pairs of the wheels on one truck are sliding. However, the buzzer does sound steadily, but the locomotive should be stopped. 47. If it is possible for the wheel slip relay to stick and cause the buzzer to sound continuously, this should be checked if there is no indication of wheel sliding. 48. 3 automatic safety devices. Low oil pressure switch. Lubricating oil pressure drops below 20 psi. Pounds. Low oil pressure switch breaks and circuit to the governor solenoid. When this occurs, the valve is open to the governor and operates. Shut off the supply of the fuel oil cylinders to the engine. 2. The ground relay. This electrical device operates to unload the generator. If there's a ground at high voltage system, when the relay operates, the armature is pulled into the latch automatically. Resulting circuit changes cut down with the current output generated to nothing. This will cause the engine speed to speed up. When this occurs, the throttle should be moved in the idle position once, otherwise overspeed trip may operate shut down the engine. 3. The overspeed trip, the lever on which the Bosch injection plunger pump assembly throws oil out and trips and shut down pins. Engine speeds exceeding 740 revolutions per minute by about 100 revolutions per minute or more. When the overspeed lever trips, the injector pump plungers are made inoperative. The engine shuts down for the lack of fuel. Alright, 49. If the engine shuts down automatically because of low lubricating oil pressure, there's nothing that can be done with the oil pressure, but it will build up properly. Lubricating oil level may be too low, oil level may be too hot. If it may have become diluted in a later event, but the crankcase can be drained and refilled with fresh oil. If the engine fires on cranking, it will shut down again. If the engine start is released before the oil pressure has built up to at least 20 pounds. 50. The ground relay inside the electrical cabinet, it should not be reset unless the throttle in idle position is reset by lifting the red handle. If the relay armature closes the latch again, as soon as the throttle is moved away from the idling position, if the ground cannot be located, the relay can be made with the inoperative emergency by opening its switch. 51. Ground relay switch with a knife blade type located with the relay with the most locomotive, but on others it's on the wall of the electrical cabinet behind the door, not in plain sight. When this switch is open, the ground relay is cut out. When the safety protection against the ground circuits is eliminated, switch should never be opened to permit movement of the locomotive except in an emergency when it is possible to clear the main line by moving the locomotive at just a short distance. 52. Overspeed trip levers alongside the Bosch injector plunger pump assembly. The lever trips the relay 6 cutout pins of the 6 plunger pumps so that all the pump plungers can become inoperative. To reset the trip lever, each of the 6 cutout pins must be pulled out by hand, turned so that the finger of the shaft of each pin rests on the cutout shaft but is clear from the notches of the rack. The tripper lever can be pulled out of the reset position. When this has been done, each pin will have been turned again if it has not entered into a notch on the rack at its position. All of the pin handles will stand nearly vertical when reset properly. Failure to reset the pins properly may prevent the trip lever from functioning, shutting down the engine should overspeed occur again. Alright, miscellaneous operation. Running through water and floods. The track is flooded with water deep enough for the reach of traction motor. The motors were ruined if allowed to become water soaked. The traction motors have clearance of only about 4 to 5 inches above the top of the rail. If water is high, the locomotive must be moved to the under must not be moved in any circumstances. If the water is less than 4 inches above the rail, the traction motor will not be harmed. The locomotive running through water slowly enough to prevent splashing 2 or 3 miles per hour should be limited to the speed. 54. Running through rain. The only difficult running through rain is a certain amount of water is drained from the radiators by the fans on switchers. Not particularly difficult to experience on road locomotives. A certain amount of water will come into the engine compartment. This cannot be helped, but ordinarily will not do no harm. 55. Running through slush. Not only much there's not much you can do about running through slush. If the traction motors are waterproof, no harm will be done. However, the traction motors are seldomly completely waterproof, so there is a chance some damage may result. 56. Running through snow. No difficulty experienced running through ordinary snow. Diesel locomotives will buck drifts before better than steam locomotives. However, the switcher and plowing through drifts at low speeds, snow may cave in between the two trucks. Therefore, it's necessary to back up the snow may pack under the traction motor, lifting a truck so that the locomotive will lose traction and will have to be shoveled out. 57. Operating over railroad crossings. Whenever a locomotive approaches a railroad crossing at a speed more than 5 or 6 miles an hour, the throttle should be eased off before passing over the crossing. It is not necessary to move the throttle to clear idle position. The electrical control cabinets do not return to the starting position when the throttle is just eased off, but they will if the throttle is returned to idle position. Normally, operation can be resumed immediately after the locomotive has passed over the crossing. 58. Pumping up air pressure rapidly. Speed of the air compressor is proportional to the speed of the diesel engine. Normally, the compressor supplies air fast as needed. It's necessary to pump up the pressure rapidly with the engine is idling. Reverser handle should be placed in mid position where the no power will flow through the motors. Throttle can be opened but vary gradually until the speed of the engine increases to about 400 to 500 revolutions per minute. This will increase the speed of the air compressor accordingly, but the same procedure can be followed with the road locomotives when the train is drifting along a long grade. 59. Operating standards. The wheels of the diesel locomotive are likely to slip when those of the steam locomotive when the train is being started carefully. This is because of the uniform turning action with the torque of the traction motor. When needed, sanders are used about the same manner as of the steam locomotive. If the sanders should be used making a stop, the sanders should be operated before the brakes are applied, just as they would be on a steam locomotive. 60. Shutting down the engine when on the spot. There's no reason with a diesel engine Alco GE switcher should not be shut off during warm weather. If the locomotive is standing still for a half or hour or more in the cold weather, all shutters should be closed and the engine should be left running at idle speed to prevent the possibility of the water in the radiator freezing. 61. Speed limit is 1,000 horsepower. Switching maximum permissible speed of 40 miles per hour. The sharpest curve on which it is designed to operate without cars is 50-foot radius. The same limits, if applied with a 660 horsepower switcher, the road switcher can run up to speeds of 60 miles per hour. Train load. The weight of the 1,000 horsepower switcher is 115 tons. The weight of the 660 horsepower switcher is 99 tons. The 1,000 horsepower switcher has a started tractive effort about 69,000 pounds. The builder recommended the train load should be limited bolts of any length of the ton, which the locomotive can pull at least 8 miles per hour when the engine is working at full power. Similarly, with the starting effort of the 660 horsepower switcher is about 49,700 pounds at the minimum speed for pulls of any length of full power to 6 miles per hour. The slow speed limit figures refer to continuous drag lasting for an hour or more. Continued overloading will cause excessive heating of the traction motor. 63. Deadheading. Before locomotives move even a short distance, another locomotive with a reverse drum and electrical cabinet should be moved into the neutral position. Hand is necessary by hand if necessary, and locked there. If there is air in the control reservoir, it should be bled out. The throttle should be in idle position. Both brake valves should be in the running position. Alright, 64. If the locomotive is to be hauled with a dead in a train, the same procedure should be followed, but in addition, cutout cock below. The automatic brake valve should be closed and the dead engine valve should be open. The dead engine valve will be found under the running board back of the battery box engineer side. Main battery switch should be open. There is no current in the reverser when the diesel engine is not running. However, it will be dangerous to touch this reverser in the electrical cabinet if the engine is running and the throttle is open. 65. Oiling around steam locomotives. When steam locomotive men will note the absence of the usual oil cans tallet pot in the cab. There's no regular oiling around it to be done on a diesel locomotive as is necessary on a steam locomotive. The only exemption is side bearings. The truck bolsters need only oil occasionally. About the only other servicing required during the trip to give the handle of fuel oil filter near the fuel pump of the lubricating oil filter at the right front corner of the engine and a turn or two every few hours. 66. The oil reserve on the governor has to be kept in about half full. The cutoff rack shaft on the Bosch injection assembly has to be kept cleaned and oiled. There regular intervals at which the oiling must be done. 67. Engineers operating diesel locomotives must refer to the gauge of the instrument panel from time to time in order to check the engine cooling water temperature, fuel oil pressure, lubricating oil pressure, air brake pressure. When the locomotive is operating, the engine cooling water temperature should range between 150 to 170 degrees. Fuel oil pressure should be about 35 pounds. Lubricating oil pressure should be 35 to 45 pounds. Control air pressure should be 70 pounds. Air brake pressure should be in accordance with the standard of each individual railroad. 68. If the engine cooling water temperature runs too high or too low, adjustment of the shutters should be correct condition. The cooling water temperature raises rapidly, reaches 190 degrees. The engine should be idle shut down until the trouble is located and corrected. 69. Speaking generally, cooling is controlled by operating shutters above the fan first. As more cooling is required, radiator shutters on the fireman side should be open next. Shutters at the radiator engineer side should be open last. Shutters in the oil section on the radiator back sections of the engineer side should not be open except in warm weather when it's apparent that the oil is too hot or is getting thin. 70. It is well to check with the ammeter occasionally while the diesel engine is working under the load to make sure that the auxiliary generator is charging the battery. If you hand an ammeter points to the charge side of the scale, it shows the battery is being charged. When the engine is being started, the battery is being drained faster than being supplied. The hand will swing over to the discharge side of the scale, the same as it does on an automobile. Alright, general information. 71. Control air pressure air pipe to the electro-pneumatic valves comes from the main reserve through the reducing valve of the small storage reservoir. Reducing valve reservoir are left on the left side of the locomotive underneath the cab. Reducing valve is set for 70 pounds. There is one reason why there should be at least 70 pounds of air pressure in the air system before attempting to operate the locomotive. 72. The cooling water system of the 1,000 horsepower switcher holds 240 gallons. The cooling water system of the 660 horsepower switcher holds 220 gallons. Lubricating oil space crankcase of all Alco diesel engines is designed to hold 85 gallons of oil, and the fuel oil tank of each switcher holds 635 gallons. 73. Ordinarily, the engineer can hear the transition contactors when they pull in and change circuits from series to series parallel. This is not necessarily true with the other transition changes. 74. The drain valve of the engine cooling system of the drain of the engine block. The valve must be kept closed if the engine is running other than wise. Enough of the cooling water will flow back through the open valve to prevent proper cooling of the engine. 75. And the engine does not start running when the fuel pump is switched down, pulled. It can shut down by tripping the overspeed lever. Engine also can be stopped in emergency by pulling the emergency fuel cutoff valve knob. When the storage battery is fully charged, there is a tendency for the hand ammeter to flicker back and forth rapidly. No harm is done. No attention needs to be paid to this condition. Alright, examination questions, and then and that was Railway Education Bureau, subject diesel locomotive operation running Alco GE switchers, 1945 DCBOL, Omaha, Postal Zone 2, Nebraska.